Exercise 2.3, question 5. Give examples of polynomials px, gx, q of x, and r of x which satisfy the division algorithm, and then there are certain conditions. What is the division algorithm again? If you divide px by qx, that is your dividend is px, divisor is gx, then according to the division algorithm, they will always satisfy this relationship. And what this relationship really has, it's nothing but it's saying that the dividend is equal to divisor times quotient plus remainder. The remainder can either be 0 or its degree will be less than degree of gx. It can never be equal or more. So this is about the remainder and the divisor, not about any other things. Now here in part 1, you want the degree of the dividend to be equal to degree of the quotient. So how am I going to do this? I can't already know what the quotient is, right? So think properly. In writing down the polynomial, first of all, the dividend, you don't have to give any thought. Just write about anything, say x squared. I'll just keep this as simple as possible. Now what I want is I want my quotient to also have a degree of 2, because that is what the degree I've taken here. So when is it that my quotient can have a degree of 2? Think about it. It's x squared here and I want x squared here as well. So the only thing possible is that here I should have a constant, because otherwise it will increase the power of x. So let's do one thing. Let's have a nice number with this here. So the dividend is this, and let's have the divisor equal to just the number 4. Now just check division. Let me do this here. So this is 4x squared. Let's write this down properly. Here you go. Now if you actually divide this, what's going to happen? You're just dividing 4x squared by 4. You will have x squared here, and then 4x squared is what you will have here. Change the sign and it's done in the first step. So I had to take, it didn't say it had to be complicated or anything, and we have exactly what we wanted. And we also have to give the dividend, the divisor, the quotient, and the remainder, all of those things. So now you can see all of those here. Here's px, dividend, here's the divisor, here's the quotient, and here is the remainder. And as required, my dividend has the same degree as my quotient. Try part 2 before you see my solution. Alright, I hope you tried. In the second part, you want the degree of the quotient to be equal to the degree of the remainder. Yet again, let's think quotient and remainder should have the same degree. So let's try creating something here. Suppose my quotient is x, and now I want the remainder to also be x. Now if I follow the division algorithm, then I can really say that my dividend, the px that I'm looking for, should be equal to divisor multiplied by quotient, which is x for me, plus the remainder. Now let's randomly take anything for gx. Suppose I take this to be x squared. No, that can't happen, because the remainder, yeah, that can definitely happen, because the remainder just has to have a degree smaller than the divisor. So my divisor can have a greater degree. So if this is x squared and I put this x squared here, it's going to be x squared times x plus x. Now you do the multiplication first. X to the power 3 plus x. That's it. This is your px. So it's totally random. Take any two things, the two things that they're telling you about in this part, and the others you can get through the divisibility and remainder equation. So overall, let's write down what you had finally. The dividend px is x cubed plus x for us. The divisor is x squared. Let me clear this up. The quotient is x and the remainder is also x. And a quick check of the condition that you wanted. 1 second. Alright, is that the degree of quotient and remainder should be the same, and we can see that the degree here is 1 each. Now let's go to part 3. This time there is no condition on anything other than the remainder. So we're given that the remainder should have a degree of 0. Now this can happen when the remainder is a constant. The degree of any constant, 2, 3, 5, whatever, the degree is always 0, because degree is really what? It is the power of the variable, right? The highest power of the variable. So in this case, if you see, it is 2 x to the power 0 or 3 x to the power 0. You can see the powers are 0. So all I want is that ultimately my remainder should be a constant. Let me just randomly choose 1 here. Now as for the others, how do I decide? Let's use this division algorithm. You have dividend is equal to quotient times divisor plus remainder, that means it should be 1. So let me choose something random for these two. Say my divisor is x and my quotient is also x. In that case, the product of these two is going to be what? X squared, right? So if the product of these two is x squared, then since I want to find out px, which is this product plus 1, that means my px is x squared plus 1. And we're done. I again had random expressions for the condition, and I found everything else accordingly. Now let me write all of them down. Px is equal to x squared plus 1. You can try this, you should try this with more examples that you create yourself. Gx, the divisor, is equal to x. Quotient, which is q of x, is also equal to x. And finally, remainder is equal to 1. So the only condition we had to take care of was that the degree of the remainder should be 0, and we have taken care of that. And we're done.